All right, so let's look at the platform. I think I just did that. Okay, so here, today, you should have finished normal distribution by today, and then you're going to spend this week studying linear regression. Next week, we're going to meet and talk about linear regression. And then at 1 o'clock, I'm going to post your first test. That's the plan. And you'll have 3 days to complete the test. It means that you can enter the platform and exit. They will be multiple choice questions, but you have to share the evidence or your solutions with me. Okay? So comments about that so far?
In the test, can we go back if we answer one question?
Yeah, you can go in and out. Yeah,
Okay. And back
submit, you can
also.
resubmit, you can go back, you can, yeah.
Okay, perfect.
Yeah, it's just the way I do it.
Okay.
Yeah, so any other questions? So
the evidence, how is the evidence? The evidence is written, or it's more the numbers? There is a space for to show the evidence.
What I'm going to do is I'm going to post the multiple choice, just like the quizzes on the platform. So it automatically grades. That's going to save me time. But then you're going to upload, you're going to scan, you're going to write your answers on separate pages, and you're going to scan them or even take a picture and send them up through the platform. There will be a entrega, botón de entrega, like a folder way to submit. And that way you can change those too. If you submit them and then you want to change something before the deadline, you can change them, right? You can resubmit. And obviously you guys aren't supposed to work on this together. This is individual work. So I'm trusting you. That's the best I can do. So you are going to submit those to the platform, and then that will provide me evidence. So if people are copying, I can pretty much tell, because it's the person copying is always going to make some sort of mistake, and it's obvious they're copying. You know, it's evidence. It's evidence. I'm like a forensic with the notes. I mean, with the reading your hand or handwritten notes. So it has to be in your handwriting. No Excel spreadsheets. No Word document. It needs to be with your pen. Okay, your evidence. So submit it, and it's evidence that you did it. And it's also good because if you misinterpret a question, you have your defense there that you've misinterpreted and you solved it. And if it's a good argument for your misinterpretation, I will give you either half the points or all the points. So it's for your own good. Daniela.
How much time do we have to submit the notes?
It's just 3 days for the whole thing.
Okay.
3 days, because I want to make this as flexible as possible for people who are working. But, you know, the weekend, maybe you'll still be studying. So I'm allowing you time to catch up as well as write the test. So that's my goal. So then the following week, this is the problem. So you're going to have work. You're going to do it for Saturday to Sunday, Sunday to Monday, Monday to Tuesday. Then you're done the test. You should be done. You should be able to do this test on Saturday. That's really the truth. But this is for people who have weekend obligations. They have religious commitments, or they have work commitments. I'm trying to do my best at accommodating everyone. Then you're going to submit it as soon as possible, hopefully long before Tuesday evening. But because you need to be working on the next unit or next module. The next module, I have that you should be done module 6, which is probability, which is the one that the students, I think the probability one is okay. I think it's after the test you think, oh, I can relax. No, you cannot relax. You have to get into probability right away. So maybe take a break for Wednesday, but then you have to get back Wednesday night. This will cover everything that we've done so far. The test is on modules 1 through 5. Well, there's nothing really in 1, but 2, 3, 4, and 5. So it means that you will be studying regression this week on your own, and then we'll meet on Saturday to review regression before the test, before I post the test at 1 o'clock. So everything I've put so far. And any other questions? So this is our goal. Let's see where you're at. So I want to talk about the normal distribution today, but if you need to go back, well, let's see. Let's talk first about the GDS and see if there's any outstanding issues. And then we can go into the normal, see how much you did. So with GDS,
Morning. I have a question in respect the exam. So can we, in the part of the evidence, can we submit our calculations from the iPad? Like everything writing down, but
oh, you mean if you write on the iPad?
Yeah.
Yeah, if you know how to make a document and submit it, yeah. That's okay. But that's handwritten. That's not.
Yes, handwritten. Yeah.
Yeah, it's okay. As long as you you know how to make a document to upload it.
Perfect. Thank you.
Sure.
Professor, I have a question. Is there only one, there is only one quiz on Connect, right? The one from the first unit, well, the second one technically, or is there one I'm not seeing?
What do you mean quiz?
Well, I know on Connect, like the exercises.
Oh, on Connect. Oh yeah, Connect. Yeah, I Connect now. I'm gonna post some Connect exercise for NOR and GDS, but I will make them do so NOR and GDS and make them do after the test. GDS and NOR, and then we have then we have regression, right? So yeah, I'm going to do that. So NOR and GDS, I'll make an assignment and it will be due after the test so that you have time. Those Connect assignments are really, I don't want you to be focusing on the Connect assignment. I want you to be focusing on my material. The Connect assignment is to give you extra points. It's to help you, okay? So that will be due after the test so that you don't waste time. If you want to do them, that's fine, but that's not my focus. My focus is the material here. But I need to give you I want to give you some assignment points and something easily graded that I don't grade because I never have time to grade. I tried so many times and there's just no time in my week. So that's going to be up and I'll have it due on the Wednesday. When your mind is fresh and you know all the material, it'll be easy to do the Connect assignment. But you should do it anyway. You can do it before if you like. Like I said, I'm going to post it today. And then I will post the regression assignment for the following week. So you get a week. You get a week for the Connect assignments. I extended the last one because some people had trouble with getting the book. I think maybe there's still someone who has trouble with getting the book. Not sure if that problem was resolved. Any other questions? Anyway, any kind of logistic questions? Okay, so now I'm going to ask you about GDS. Any of these components, any of these pages, I saw that Elizabeth wrote some nice comments on my videos. Thank you very much. Saying that these were helpful. So I agree. I think if you're not watching these videos, you're missing the course. Like these are the foundation where the pages are explained page by page. And I warned you at the outset, this course is about practice, and you're not just going to get what you need from the discussions that we have. These are supplemental and to clear up or clarify anything that you don't find in the videos. But if you haven't watched the videos, then you really haven't had the course. You haven't experienced the course. Okay, so no comments about GDS. As far as that quiz goes, there was one question on the quiz that I did find a little bit weird. So I have to look at the last quiz. Sorry, let me go back. The last Connect assignment, there was one question that I agree with one student that was funny. So I couldn't do anything while it was open, but I will go through and see who I should reward points because it was very confusing. It was the one that said, what did it say again? It said, was it talking about, blocking? It was blocking. It was talking about the treatments getting, or all of the sample getting the treatments. I thought it was it was confusingly stated. So I'll have a look at how you guys did on that. And add a point if you lost a point for that. So I'm going to say I'm done with GDS and go to normal. This week, we want to focus on the normal. Again, you have page by page videos. If you haven't finished, I get it. But in general, if you ever took a statistics course, you've learned the normal distribution. I bailed up the theory about the normal. This chapter is the most important. Sorry, not chapter, but this module is the most important module because you're going to use normal for the last set of modules. So you need to be an expert at the normal distribution. So, how far did you get with the normal distribution?
At least myself, I saw all the videos. I have some doubts.
Oh.
I haven't finished the homework, but I have some doubts with the exercise I tried.
Okay, you're in good time then. You want to look at the homework then? Should we look at the homework together?
I would like if the rest of the team agrees.
Yeah, how does everybody feel if we start with the normals and then we can do some extra problems that I had?
Yeah, I'm okay with that. Yeah.
Orlando, are there any particular questions that trouble you?
Yeah, I put in the chat from the module 4 the in page 6.
Oh, you mean back to the notes? You want me to go back to the notes? Okay.
Page 6, the last exercise, and page 13.
Sorry, I'm going to open the notes up then. So these are the English. Yeah. Page 6, problem 3.
Mm-hmm.
And here, okay, so let's go through Orlando's. Yeah, just put them in the chat. Put your questions in the chat. And I can work with that. You can see? Maybe not. Hold on.
Yes.
Oh, you do?
Yes. No,
sorry. No, you don't see that. You don't
whiteboard.
see. Yeah. Wait. What happened here? I'm going to put my iPad. Too many steps to remember here. Okay, so now I'm going with iPad cable. There. You see me. Okay, so you can see that? No problem?
Yes.
All right, so let's see. This problem refers to this normal distribution. Where was it? Well, it's the, okay, so I know that it's the normal distribution where X is distributed normal with a mean of 64 and a standard deviation of 2. So for this problem, so this is how I write it. And so for this problem, at this point in the notes, I just taught you about the 68, 95, 99.7% rule.
Mm-hmm.
And that's what I want you to use. So you're supposed to draw this out, putting, you're going to draw this out. You have 68 in the middle. And then you're going to go by 2 for 1 standard deviation, not 68, 64. Sorry for the confusion there. $64, and then 66, 62 on that side, and then 68 and 60 on that side. All right, so I want to identify the 60, and keeping in mind, so I explained that to draw this, it's concave, but then it curves up, right? That's what I kind of explained to you. It's not a great drawing. Those videos took me forever to make. Anyway, that'll have to do. And so here, at 60, we recognize that's 2 standard deviations away, and I put it with its pair. It's paired with 60, no, not 60, yeah, 68. It's paired with 68, right? Because that's 2 standard deviations, that's 2 standard deviations, and I know that's 95% in between. But this asks to go all the way to the right of 64. So I have something else over here, this. So how much is this? If this is 95 in the middle and the whole thing is 100, that means that there's 5% remaining. So that puts 2.5% here and 2.5% here. So now you see the answer. Orlando, are you with me? So it's 95 in the middle. That means it's 100 minus 95 outside, or 5%. But because there's 2 sides and it's symmetric, I have to divide that into 2.
Yeah, I got that. But how do you get to 97.5?
And now you add, because I have to add.
Ah, yes, yes.
You got it? You
Yeah,
add
got
them.
it. I draw the double shape. I draw it differently, so that's why I was lost.
What did you draw differently?
Yeah, I was working at the left side instead of the right side.
Oh, yeah. Oh, you were going that way. Okay, so follow always this arrow. This arrow points that way, so I'm going to point the arrow that way to remind myself, all the way that way. Good. And I call these, I mean, I don't know, that's a tail. It's like the tail, right? Push it out. I'm going to say each. Well, I guess tail is fine. Usually we reserve the word tail for the outlier tail, but this is still a tail. It's the end. All right, so next you ask for, so I'm going to go through Orlando's and then I'll see what else people have. Okay, so then page 16. Everybody's good? I'm going to continue. I'll write the answer if anybody has doubt. The answer is 97.5. I started having a cough yesterday. So. I hope you guys are taking good care. There's colds going around. All right, let's go to page 13. Problem 3. So let's see this one. Okay, so this is a backward problem. No, there's not a backward problem. Well, yeah, it's a backward problem because backward problems are where I give you the probability and you give me the z-score or the value of the variable. In this case, just the z-score. So I draw this. This means in between. When the arrows are like that, it's saying in between negative z and z.
So, Professor, that means we need to provide the positive number and negative number on the table, right?
Yeah. In between positive and negative z. That's what we want to find, exactly. So we draw this just so I can convey what I'm doing. And the fact that it's the same letter means that it's symmetric around the center, okay? So that one's z, this one's negative z, this one's z. So I can draw this as symmetric around. That doesn't look so symmetric. Okay, so then this is negative z, and this is z, and then this in the middle is 68 to 6. That's what I've translated this into a drawing of interpret. So what do we do? At this point, we've learned about the normal distribution. We learned that this is 100 on the left, and the right should be equal, like we just did this other problem.
We need to subtract, right? The 100.
Yeah, yes. So we're going to repeat what we did before just now. I can do 100 or 1 because it's all in decimals. 6826. And that's the outside. So that's the inside. So the outside should be
0.1587.
I'm worried about my labels now because I know I use the word inside and outside for something else. Let me call this between. And I'll call this the tails, right? So then that's 1587. No, wait, is that subtraction? That's divided by 2.
Divided, yeah.
Yeah, so then each tail has that. So then you put 0.1587 here and 0.1587 here. The easiest one to understand is the one on the left because the tables are all to the left. All the tables are percentiles, that is the area to the left of Z. So look on the negative table for this number. So you look So let's go to the table, page 22, and I look for 15.87. So I look inside and I look here, and here it is. 15.87 corresponds to negative 1.0. So you go inside the table and out. You do the backward operations. So the answer is negative 1. Any questions?
Why negative?
Because I went to the negative table. So
Mm,
I started on the left because that's the tables are all to the left. If I went and looked here, if I wanted this one, I would have to go to the left of this, and I have to make a calculation. So that's not as immediate because I would have to add. What would be the area to the left here of Z all the way? It would be 1 minus 0.1587. It's another number. So we have to make another calculation. Okay, Victoria. Was that Victoria? Sorry, who's talking?
No, Wilmary.
Wilmary,
Wilmary.
okay. I saw Victoria going like this, and I thought it was her. Okay, Wilmary. It's hard. I can't see everybody. I can only see 5 of you. I'm not sure if I can. I don't think I can while I'm projecting see everybody. But anyway, we'll do our best. Usually when you speak, you should pop up in front of me, or at least in the chosen few.
Good morning.
Hi.
Hi. I don't understand.
Christina.
Can you hear me?
I can see you. Yeah. I can see you, not you, but I can see that you're talking to me. Yeah, it's okay. I
got disconnected briefly.
It's okay.
I don't understand how to choose to look to the left.
Okay, so the text, sorry, the tables give you to the left. That's what the tables are. The tables are information on the left. That's why to go right to the table, I have to use the left side. So it's easier to use this left where I have the number than this left where I have to make a calculation.
Okay.
So always the tables are to the left. So you need the information to the left.
Okay.
Okay. Now, once you get good at this, you'll feel comfortable saying, well, I know that this information on the right going this way is actually for the negative because of symmetry, but that might not work in your brain right away. So just stick with the left until you feel confident, and then realize it's going to be the same on the right positive. So if you change the sign and the direction, you get the same numbers. If you change the sign and the direction. So positive going this way gives me the same number. So I'll make a note here. Okay, so because of symmetry.
Because it's like a mountain.
That's just like a very even mountain, yeah. Because of symmetry. When you change the sign and direction of I'm going to say the problem. I'm going to say sorry, I pressed something. I got to make this small. You guys understand what I mean? You get the same answer in the tails because of symmetry when you change the sign and direction of the problem. Hope that makes sense. So from if it's a positive or a negative. Yeah, I missed an L. Does that make sense? I'm trying to explain this, and you're going to see that a lot. So, and that's what I did in the exercises. I was doing things like z less than 1.65, and then z greater than, sorry, negative, and then z greater than 1.65. That has the same answer. I changed the sign and the direction of my search.
So, of course, if you change the sign or the arrow, you will be changing the like if it's negative or positive, right?
You have to change both for it to be the same answer.
Got it.
Okay, so yeah, just put a drawing somewhere. You guys should, you could maybe make a summary page of the main things. Like when you take the test, you can just look at your summary page rather than all your papers, and that's something that you would put on a summary page to remind you, because that happens. I mentioned it a lot because I want to get you into the habit of using the right tail just as well as the left tail. All right, and I also showed you how to get the answers in Excel, and Excel does the same thing. Excel uses the left side. It gives you the results of the left side. So you need to know that. And the left side is the percentile. Mm-hmm.
Professor, I have a question. On the I don't know if you have more exercise to discuss, but on the page 24, I believe it's pretty much similar to this example, but I'm not clear with
oh yeah, all these. Mm-hmm.
Yeah, okay. But I'm not clear with the question number 4.
Okay. Yeah, I'll go back to Orlando's in a second. Let's just do this quickly. Consider the random variable x, which is normally distributed with a mean of 10 and standard deviation of 25. There is a 68% chance that x will be observed to be between 15 and 35. There is a 0.15% chance that x will be observed to be larger than 85. So you need to make a drawing, right? So whenever I say apply the rule, you make the drawing and then you see which is true. So so then this would be 35, and then going this way would be minus 15. And then this would be 60. And this would be, let me know if I'm wrong. This would be minus 40. And let's see if that's enough. Okay, there is 60% that x will be observed between negative 15 and 35. So that's correct.
I believe it's 85, not 60.
Oh, sorry, yeah, that one's wrong. Wait, where are you? This is 60 because this is 60, but then the next one. Okay, so you're talking about the next one. As I just did 2. The next one is 85.
Yeah.
Right. I didn't stop. I didn't finish. So so then this one would be 85, and then this one would be minus 65, minus 15, 25. Yeah, minus 65, right? All right, so the next one, there is a 0.1% chance that X will be observed larger than 85. Yes, because that's 3 standard deviations. And this is going to be 1 minus 0.997 divided by 2. Right? Which is 0.0003 divided by 2, which is 0.0015 or 0.15%. So that's true. And then there is a 2.5% chance that X will be observed to be less than minus 40. So again, we take 40 with its pair, and the pair is here, and that's 95%. Inside, and outside is 5. So out here, it's 2.5%. So there's a 2% that X will observe less. D. Is that the right answer? Did I do anything wrong?
Yes,
It's right, Christina?
I think so.
Okay. Vanessa, you're okay?
Mhm.
Where did I lose you?
No,
Did I ever?
I'm just double checking my numbers,
okay.
but yeah,
Okay.
yeah, I believe that's the right answer.
Okay. It's fine. I mean, you guys are learning. It's okay to be confused. You can't know everything when you're learning. Yeah, I'm going to go back to, you guys can keep typing problems. I'm going to go back to, unless you have something related to this, just ask me. Don't put it in the chat because then you're going to have to wait. Okay, so let's look at homework questions 7 and 8. Mm-hmm.
Sí, no, está bien.
I think I have to upload it. Okay, hold on. Let's stop here. Okay, 7 and 8. The heights of students at a college are normally distributed with a mean. Hold on. I'll write things down and we'll go to the iPad. Normally distributed with a mean of 68.4 and a standard deviation of 2.7. In a random sample of 100,000, how many of them would you expect to have heights less than 63? Okay, so this is going an extra step. We're going to find the probability per person, and then the last step is to scale it to 1,000 students, right? So we're going to say for one student, we're going to find the probability. So if we're going to, I expect to have heights less than. All right, so this is the information. It looks weird, but that's the information. Let me write it better. 63. So to do this, by this moment, you've learned how to standardize. So to solve this, X turns into Z if I take 63 minus the mean of 68.4 divided by 2.7. And then I get a number. What do I get, Orlando?
Let me open my calculator.
Negative 2.7. Oh no, never mind.
Oh, see, I have to check just in case. Just in case. And we're all checking at the same time. I get -2. Does anybody agree with that?
Yes.
Yes.
Okay. All right, I get -2. Is that right, Christina? I like to count. I like you guys to do it, but ultimately it's my responsibility to do it too, because we don't want to have the wrong answer.
I got -2.
Okay, so it's -2. So then the probability, if you go to the table or you go to Excel, is what is it? Oh, -2, or it was -2. It's this number, right?
0.028.
Exactly.
0.0228.
8. 10 to 8.
And then, so that's per student. Right? The chance is 2.28% per student. So in other words, like 2.28% of them are going to be less than 63. So then if there's 1,000, then you're going to see it's going to be 228. Out of the options, the C. Okay. And one more. 8. Question 8.
Professor, on the same page, I have a question on norm 6 and 8 as well as Orlando.
Okay, let me do 8 and then I'll be done with Orlando and then we'll go back. So let's do 8. So this looks different. Let the random variable y represent, so what did I just say? Y be normally distributed with mean 1 and standard deviation 0.5. Okay, so let's write that down. Okay, so it's a backward problem. It's confusing because it's using different letters and it's confusing. But I can turn it into X and little x and you will see it looks the same as before. So let me show you what I'm doing here on my iPad. So this is what they told you, right? So y is distributed normal. So if I wrote this as x is distributed normal 1, 0.5, and then wrote probability x less than little x equals 0.03, now you know what to do. It's just throwing you off because it's using different letters. But it's a backward problem, so we're going to solve it 2 steps. First, sorry. We're going to, step 1, right? We're going to solve it for z. And going to the left, if I was to draw this and mark z, where would I put my mark? On this side, over here, where does it go? How do I draw this?
To the left.
On the left side, right? So I draw it here, and I begin with z because then we're going to do the transformation. So z equals question mark 0.03.
Yeah.
So then find z using the table. So I'll put more zeros on it. And then we'll do step 2 and convert it. So how many standard deviations? So we begin with the concept, how many standard deviations from the mean do we have to be below? That's what that says.
3.46 negative.
Okay, so C equals negative 3.46. Is that what everyone gets? So you have to go to the table. You look on the negative table because it's on the negative side, and you look for point 0.0, I think you got too small. It's just 0.03. You used percent. No, it's too small. So 0.03 is down here.
It could be,
I think
Sorry, not down here.
1.87, 1.87. Or
Yeah, this one is
or
the best, right?
8 is the smaller. Yeah.
Yeah, 1.888. 1.88 is the closest. Does everybody see that? So Orlando, you just added 2 zeros.
sorry, Professor, I just made a mistake here.
It's okay. If you thought it was a percent, but it makes, I understand what you did. I understand what you did wrong. Okay, so then this is the answer now. So negative 1.88. So So that's the answer for 0.0003. So C equals negative 1.88. Are we finished? No, we need to do the translation, what I call unstandardized. So you say X equals Z standard deviations from the mean, and now you fill everything in. Z is negative 1.88, sigma is 0.5, and the mean is 1. And that should be the answer.
Mm-mm. .06.
See? Yeah. 0.06, or the answer is C. Okay, any questions about that one? Ready for the next one? Let's do number 6. Someone asked for number 6. And then I'll go back to the questions in, oh wow, there's 15 messages. Let's see what is happening. Oh, the answer. Okay, thanks guys. Okay, let's look at 6, and then we'll take a little break. So 6 says, the random variable X has a normal distribution with a standard deviation of 8. So here you're going to look for a different variable. But let's write down the information just like before as much as we can. So I'm going to transcribe X has a normal distribution with a standard deviation equals to 8. So I don't know mu, in other words. And then you're told that if X greater than 25 equals 0.9505, find mu. Okay, so what do I do? What should I do? This looks like the last problem that we did. It's a backward problem, but I don't know mu. But I do know little x. I know the value. So it's a trade-off, but the same process. Let's complete the same process. So step 1. Step 1 is find the the number of standard deviations that marks this. So it's saying that X is greater than 25. So where do I put my, where do I mark? On the left or the right?
I think it's the right side, but maybe I'm wrong.
If I put it here and I have to go this way, that doesn't leave a lot, you see? So it has to be over here because I have to go this way. The arrow tells me to point this way. So it's got to be over here to get 95 because here is 50. So I have to be to the left. Is that okay? So I got to be over here somewhere. And I do the same thing I did before. I want to know how many standard deviations away I have to be to have 9505 that way. This is a good question. So what do I do now?
So you find C for 0.9505, or well, the difference actually.
Exactly. Yeah, exactly. You got it. So this is going to be the right side, but the tables only give us the left side. So I need to get the difference. I need to find what the left side is. Okay, so anyone who hasn't gotten this far or reviewed all the material, just realize you'll see this. We repeat. We just start repeating. If you think that you're learning something new with every question, you haven't studied enough. When it starts repeating, that's when you know you've studied enough. So keep going until you see the pattern and the connection between these problems. 0.9505. Well, I can do this actually in my head, but I'm going to just do it on my calculator. So you're going to look up this number on the left and then correspond it with the Z-score. So what do you get?
1.65, I think. Maybe I'm wrong.
With a negative, right?
Yeah.
Negative.
Okay, let's go look at it. Let's go look at it together. So here's my thing, and I want to look for the number 0.0495. And it's around here somewhere, it looks like. 0495. Okay, so right here, right? 0.0495. It's negative 1.65. That's what you said. Let me clean up my table. Let's continue. So that's going to be with a 5, negative. That's step 1. And step 2 is translate. Step 2 is X is equal to Z standard deviations from the mean. As I say the words, I can write the symbols. And now I just put the things that I have inside. So I have Z over here that I found. I have sigma here. And I don't have mu, but I have X over here. You see, so you just have a different set of information. So X was 25. Z was calculated as negative. Don't forget the negative, 1.65. Sigma we have as well is 8 and plus mu. So now you have to do some algebra, but it's not so heavy. You can do it and find mu. Just be careful about the sign. Don't lose the sign. Anyone want me to go back? I can go back, repeat what I did. We're going to finish this and take 5-minute break. I'm going to make some tea.
So it's going to be 38.20
to 25. That sounds good. 25 equals, and then you multiply 1.65 by 8. that's negative 13.2 plus mu, but I want to add that to both sides. So it's 25 plus 13.2 equals mu. So mu is 38.2, which is D. All right. Okay, let's take 5 minutes break. I say, oh, let's make it 10:15. Do you want 10 minutes?
Yes.
Okay.
Yes.
10:20. Okay, let's take a 10-minute break. It's fine with me. Okay, see you in a bit. I'll pause the video, but remind me to turn it back on.
Can you guys hear the professor?
No.
Oh, then Professor, I think you're on mute. I cannot hear you.
The setting is from my AirPods, so I had to put them in or change the setting. All right. I just said, let's continue. We've answered the questions for Orlando. And let's go to Victoria, who said she had questions from Module 4.
Yes, and you already answered it. It was the number 6 from the homework and the number 8. So I'm having a problem with the type 2 problems and the understanding. So I noticed on the homework where you were explaining. So yeah.
Okay, so you're okay now? You're better?
Yeah.
You can
Yes,
review
thank
the
you.
video. Okay, good. Good. Quiz 4.2, Carolina. Let's go see quiz 4.2.
Yeah, it was question number 3.
I'm just going to open it up. They're randomized, so they might appear different for me. What was it? What did it say?
I think the order of the questions remains the same, but the answers are randomized. At least
Okay.
in my attempts, that's how I see it.
Okay.
It's
So 3, the percent of observations.
let me check.
Yeah, check.
Yep. Yeah, that's a
The
one.
percent of observations. Okay, so there are some challenging problems in the quizzes, and this is one of them. So don't feel bad about it. Okay, let me share this with everybody. Or maybe I am sharing. Let's see. Yeah, okay. So number 3, the percent of observations that are suspected outliers according to the 1.5 times IQR rule is the same for any normal distribution. What is this percentage? All right, so if a distribution is skewed, you use the 1.5 times IQR rule to identify strange or outlier values. If the data are symmetric, you use 3 standard deviations to identify outliers, right? And we know in the normal distribution, the number or the percentage of outliers is 0.3%, right? It's 0.3% or 0.15% on each side. But I put these things together here where you're going to use the rule to check the normal distribution and see what percentage are considered outliers by that other rule. It's just practice. It's just a matter of giving you guys practice. Nobody would ever do that, but it's going to show you in the end that the rule for symmetric gives a different result than the rule for skewed. All right. So I can do this one. I'm going to put up my iPad. Oops. I'm going to do it this way. Okay, so I'm going to do some drawings here. Okay, well, 1.5 times IQR means we need Q1 and Q3. So in a normal distribution, this is just a normal distribution. Where's Q1? Is
25%.
Is it over here on the left or is it on the right? Where's Q1? Q1 means the value, right? It's on the left. It's going to be the value with 25% of the observations to the left. So actually, let's use the Z. Let's use Z. Should we use Z? Does it matter?
I use
think
C. So
yeah, you got to use Z because otherwise you don't have any numbers. So
yeah,
you have to use Z. Okay, so I'm going to use Z, not this one. So then Z, oh, sorry. So it doesn't matter really, but this is easier. So Z would be what? It's going to be a negative to put 25% to the left. That would be Q1. So you have to go inside the table and look for 0.2500. What do you get?
Can you repeat that one?
Okay, so we need Q1. Q1 means 25% of the observations are on the left. So that would be here. So where is it? Yeah, what value is that?
Okay.
0.68.
Yeah, negative.
Negative, yeah.
That's the tricky part. Okay, 0.68. Do you get kind of in between those some? I think you get in between. Let me see. So I want to go 0.25, 0.025, no, 0.25. 25%.
I find 0.40. Oh, no, go ahead.
No, I'm okay. Keep going. So between here, 0.25, 0.25. Which one is closer? This is 14, and this one is 17.
Yes.
So it has to be this
14.
one.
I choose the 14 is the closest.
Yeah. So it's okay. 0.68 is close, but 0.67 is better. Okay. So this one is closer. Okay. I know that because I've done this problem so many times. The students have trouble with it. It's confusing putting together different concepts, but you'll appreciate it when we're done. So it's 0.67 negative. Now, because of the symmetry, what's Q3? Q3 is where we have 7500 on the left side, but we also have 0.25 on the right side. So what would this be, Q3?
That would be positive 0.6.
Excellent, right? Because it's in the same place, yeah, on the other side. So that's a positive. So now let's calculate the IQR. I'll let that sink in. And now calculate. So there's many steps here. It's not hard. You just have to endure, keep going. So Q3 is 0.67 minus negative 0.67. So you're basically finding the distance between those.
The result is 1.34, right? For
if you add them, yeah.
Yeah.
So that's the distance between here. So that's the IQR. And now what's the question? Oh, you have to find how many observations. So now we have to take now we have to take Q3. We have to use the rule to find the outlier. So we can do it on one side, Q3 plus 1.5 times IQR. So the numbers are 0.67 plus 1.5 times 1.34. And what do you get?
it's 3.54, I believe, according to my math.
Okay, you guys, let's you guys, the rest of you try it.
Oh no, no. Hold on, never mind.
I wrote down
2.68.
2.68, I think.
Okay. Yep.
Okay, I'm gonna try 1.5 times 1.34 equals plus 0.67, 2.68. Very good. Thank you. 2.68. So now let's mark it. Let's move all this. Okay, so where's 2.68? So that's going to be 1. So let's mark it here.
So yeah, so I believe if the middle between negative 67 and positive 67 is 1.34, yeah.
So according to the rule, it has much more outliers. Right, 2.68. We really should start at 3, right? That would be the outliers. But now look for the outliers at 2.68. You can go on the left, you can go on the right. It's on both sides.
So it could be negative and positive?
Outliers on both sides, yeah, because it's symmetric. So it has to have outliers on both sides. So according to the rule, there's outliers on both sides. We have to check both sides. And so the normal distribution has outliers. It's created with outliers. 0.3% are outliers. But how many? So the thing is this. So 0.3% of observations are outliers using the rule for symmetric distributions. So the question is, what percentage are outliers using this rule? Well, it's going to be more because we're starting at 2.68. So look up negative 2.68 and what do you get?
Then negative or positive?
Oh, this is the easier one, right? Because go to the negative table.
Uh, 0.0037.
Let me check. 2.68, 2.68, 2.68, yeah. 0.0037. And then it's also 0.0037 on the other side.
Yeah, because it's the same distance.
Okay, anyone who's if I've lost you, don't worry, we're going to recap, review what we just did. Okay, so we have percentage of observations on the left, that percentage of observations on the right. So the total is $7.4, right?
Why is 74%? Right, but why?
Because I added this one and this
to
one.
The
So it's 0.0037 times 2.
But the 30. So I have a question. The 37 to the left is not negative.
This is probability.
Right. All right.
I know. I'm sorry because there's so many steps. You have to keep your head above water. We did a lot of things here. This is like the hardest problem of all the problems, I think. But it's not that it's, once you've seen it, you can repeat it. So practice this one just to keep your head straight. So we're using the wrong rule, but I'm trying to show you that we have a different rule for symmetric and a different rule for skewed, because otherwise the normal distribution would have a lot more outliers. Okay? That's what it's trying to say. That's what you're practicing. But it's a lot of in and out. So your head is spinning because we're going from Z then to probabilities and then no, probabilities to Z and then back to probabilities. It's confusing. So the answer is this one. So the answer should be, the answer should be D, 0.7. And we have to test on both sides because the normal distribution is flat. So remember that this is normal distribution is a subset of symmetric distributions. Not all distributions are normal. This is very specific characteristic.
Okay, so let me recap to see if I understood. Yeah. So we first start by saying that Q1 will be 25% and then Q3 will be 75%. We find the corresponding C values, and then we do the calculation of the IQR and the 1.5. And that's how we get the 2.68, and then we go back to the graph.
Oh, well, no, well, we get the 1.5 times IQR, and then we extend to see outliers. So we add it to Q3.
The 2.68 will be the location.
It's the location. 2.68 standard deviations above, because this is the Z distribution.
Okay, so with the location, we find the probability and then sum it up. Okay.
Yeah.
Thank you.
It's a lot of steps. You guys are capable of doing it. Good. Let's go back to the chat. Let's see. Okay. Victoria. Oh, you're done. Victoria is good. Carolina is good. Victoria said that the type 2 is confusing, but are you better now? We did a lot of type 2 just now.
Yeah, I'm better now. Thank you.
Okay, good. And you have the video. I'm going to post the video so you can review if you get stuck again. So good. So you guys are having trouble with the right things. That means that you're right on track. Okay. So you want me to give you, we still have some time, unless somebody has a question, I can give you some other problems that you don't have that we can try from other exams. Would you like that?
Yes.
Yes.
Okay. You're ready.
So sorry, Professor, before that, I have some question, but I don't know if maybe this is the time to, but I have some question about the exam. Like, how were the exercise on the exam? Like, will be like this one will be, I know you said on the first class will be multiple choice, but I don't know if you can explain a little bit how it will work. I know we have 72 hours to complete it, but
yeah, it's going to be, the questions are going to be somewhere between the homework and the quizzes. They're not as hard as the quiz, because the quiz questions are more challenging. I admit it, but I have to give you something to stretch your brain. So, so it's somewhere between those, but it's the same idea. 5 options, same idea as that. Okay, so between the homework, because the homework I consider pretty basic, some challenging problems, but pretty basic, and then the quizzes are more. The Moodle quizzes are more challenging than I would give you on the test. I think. So somewhere between that. The Connect, those are just mostly theory, and you should know that. You should, by the time you do the quiz, you should feel like pretty confident about your knowledge and get through Connect quickly. That's my idea for the Connect. It's just to wrap it up, sort of thing. So I have to post this video and the Connect assignment for next week that I said would be due after the test. So I'll make it due on the Wednesday. So you don't even have to look at it till Wednesday night or Wednesday. Yeah, Wednesday night. But if you want to just get it done, you can do it. And it'll be with GDS and NOR. And then I'll put the last one with regression after that one is due. All right. So the quizzes are happening after you know the material, just to give you guys some points. All right, so everything's working here. I want to share, what was I going to do? I was going to do the extra questions, right? Okay. And I'm going to focus on NOR. Yeah, because last week we did GDS, right? So let's focus on NOR. And then next week we'll do this for the regression. Okay, here we go. Okay, try 21. 31, sorry, try 31. Oh, wait, you can't do that one. Sorry, not that one. Try 33. Okay, try these. So 33, 34, 35. Those are all applicable. Which one is true?
Is there more than one true statement?
No, just one. I think I have to review all of them.
B. I think it's B.
Very good.
Yeah, I think so too.
Yeah, so we did discuss that, right? If you change the sign and the direction, you get the same result for the standard normal. For any symmetric distribution, this is true. So that stands out as the best one, but let's go through and see why the other ones fail. The mean of a normal distribution must always be greater than 0. No, not necessarily. That's not, the mean can be any value. Okay, let's look at C. The height of a normal density curve must always be equal to 1. Not necessarily. You have flat density curves, you have high density, peak density curves, doesn't have to be equal to 1. This is for people who are really confused to trick them. But the possible values of a standard normal variable range from negative 3.49 to 3.49. Well, the tables I give you extend there, but in fact, the values could go as good as your software is, or your table to give you decimal places, it can go very high and very low. Okay, so if you're using Excel for with the standard normal distribution, it can go to hundreds of decimal places, I understand. So you could go very far. So in terms of the probabilities can be very, very small, so that z-score can be very, very small and very, very large. All right, so this is just tricking people who think the table is the only distribution. No, that's just a representation of the distribution, and it only has 2 decimal places, and it only extends between negative 3.49 to 3.49. But if you're going to allow for more decimal places in the probabilities, then you can go further out, and you can do that with Excel.
For the
in terms of the because the table just goes to negative between negative 3.49 and positive 3.49, but the distribution goes from negative infinity to infinity. It all depends on how good your tool is at giving you the percentage on the left. And if you use Excel, you can have 0.00000006 or something like that to be a space, something like really far out. Okay, something really, this is my left side, right? Something really far in the tail. So that has small probability on the left of it. Anyway, so that's just tricking people. The higher the standard deviation, the taller the normal curve. Is that true?
It's the opposite.
It's the opposite because it makes it flatter. It has to stretch out to, yeah. Okay, good. Okay, try 34. So the answer was B for that one. You guys can take a screenshot of that. Also, it'll be in the video if you want to look back. Okay, so then 34. Winnipeg is my hometown. These are questions from when I taught in Winnipeg. It's very cold there in the winter. This one's not so hard, is it?
I'm scared to say.
It seems too easy, right? Okay, let me, I'm gonna put my iPad. So this is what we're looking at. We have negative 20 in the middle. And then for 2 standard deviations, we have, because this is 95%, we have negative 32 and negative 8. So I don't know, however you're going to do this, you're going to figure out that you basically have to divide it into 4. That's one way to look at it. So what did you do? It's kind of confusing because you're working with negatives, I guess. But if you want, if you want to know like this between here and this between here, that's negative 12 or 12. And this one is 12 as well, right? So now you can see it. What is sigma?
I'm lost.
Okay, did you follow this?
I got lost where the 12 came from.
Well, how do you calculate the distance between these two?
Okay.
I made a drawing and I got that it was 12, but I drew it. I
now
drew
you see.
in the wrong direction. Like I started in -4, 8, -20, 32.
So -20 is in the middle, and then so -20 is in the middle, and then 1 standard deviation and 2 standard deviations for 95% gives me -8. And then 1 standard deviation, 2 standard deviations give me -32. That's what they gave me. All this information was given. So
it's 12.
So now you know sigma, and it's not 12. What is it? Because each of these are a standard deviation. So this is sigma. This is sigma. This is sigma. This is sigma. So what is sigma?
20.
6.
6? Yes, 6. It's 6. I don't want to do any
Okay.
crazy calculations. I could do some crazy calculation, but the drawing tells it that it's 6. Okay, so all you have to do was use the rule. And then 95% is 2 standard deviations away. I just mark the numbers I know. I put them all there and I stare at it and I see, it's got to be 12 is the calculation, but there has to be 2 standard deviations. So that's how I figure out. I don't want to give you any.
It's easy.
It's easy if you draw the information. Yeah, you draw the information and it's relatively easy compared to what we've been doing.
Right, correctly.
Okay. If you think something, well, if you're spending too much time on a problem, you probably did something wrong. That's the tip I can give you. If you're spending too much time, so just go to the next problem and let your head clear, right? You shouldn't be spending too much time. The one that we just did with the IQR rule, that's unusually long problem. And like I said, the quiz on the Moodle platform, the quizzes are more challenging than the test will be. It's just for practice. Okay, so what was the option? What was our option? C. How many people got C? Yeah, so yeah, it's tricky, right? Because you pick 12, many of you pick 12, but no, 12 is just going to tell you the whole distance, 2 standard deviations away. So 12, so 2s equals 12, in other words. So sigma equals 6. 2 sigma equals 12. Okay, let's go to the next one. So, okay, now we have another one here, 35. So let's put these up. Let's continue with 35 and then 36, 37. We can just continue the whole thing. We can do them all. So try 35. And I'm sorry for people who have not completely reviewed the unit. You're going to have to spend today while it's fresh in your mind, go back and fill in the gaps. But yeah, you need to come to class prepared as you can be. You can aprovechar, take advantage of it. So just to review, I expect you to review the notes with my instructional videos, the competencia at the top, and then go into page by page instructions that I offer. The textbook is for reference, so that you have a reference book. But go through my materials first. Don't get lost in other materials. You have enough to work with. Then I have videos from 2 years ago that I might reference sometimes, but they're just backup. You're going to use the videos from last semester. Like sometimes I forgot to turn on the camera. That's why, I mean, the recording. That's why I had to fall back on the older videos. Not old, not from last semester. It's always the same material. You can put your answers in the chat when you're ready for 35. All right, ready for me? I'll wait for a few more. Okay. Okay, I'm going to share my iPad now. So this is the problem. This is a problem asking you to find the z-scores where z is between these two values that make 7776. So I know it's the same values because they use the same letter, but one is negative and one is positive. So it goes through the middle, in other words. So it's going through the middle, it's cutting through. And this is negative z, and this is positive z, and 0.77. This is like the third one that I do like this today. So if it's 7776 in the middle, then it's 1 minus 0.7776 divided by 2 on the left side, which gives you so 22.24%. So look, so this is the left side, so look inside. For the z-score. On the left table, right? The negative table.
Professor, I think you forgot to divide it by 2.
Oh, okay, I didn't divide by 2. Divided by 2.
You have
And
0.1, 0.1112?
Did you divide it by 2?
Yes.
Yeah.
Okay, so negative z is negative 0. No, sorry. What did you say?
0.1112.
It cannot be. Oh, this one is 1112. Yeah, that one I got. But what's the z? Thank you.
That's good.
It's negative 1.22.
Okay, so let's look for 1112 and confirm that.
I'm sorry, yeah.
Negative
Sorry.
11, 12 here. So negative 1.22. Lots of 2s, lots of 1s in this problem. Negative 1.22.
Yeah.
So that is which option?
E.
Yeah.
Letter E.
All right, because then it asks you, if you go back, it's negative z is negative 1.22 and positive z is 1.22. So it asks you for the positive. And so that's why you have to say 1.22. So it's E. Good. How did you guys get D? What did you do to get D? What did you do wrong to get D? So let's put it back to look at the answer. The answer is E. Should be E. I have a lot of D's here. What do you think you did there to get D? Any questions? Now, how did you guys get 0.76? So if I go to the table and oh, I see, because you were using the other value. Okay, yeah. You're using the 0.22 before I divided by 2. All right, I see that. I didn't divide by 2, so you had been giving me D, which is not right. Right. So let's do 36 and 37, and then we'll go. Is there anything else you want to try, or have I covered what you want to review? You're happy with this review? So let's try 36 and 37. Okay, let me start 36. 37 will take more time, right? All right, so this is the problem. These are the elements. I standardize 60 and 70 to find the number of standard deviations to be between negative 0.6 and 0.2. Is that correct? Did I do it right? So negative 0.6 is around here, and 0.2 is here. So to find the area in between, I need to take the larger area, subtract the smaller area. So negative 0.6 is this one here, and 0.2 is this one here. So 5793 would be all the area from point 2 going left, and then negative 0.6, can someone tell me it? It's 2743.
Exactly.
Mm-hmm. Did I say 2743? And when you subtract them, you get E. Good. Oh, E. And you guys got it. Okay, now try 37, and then we will stop. Well, if we have a little time, we can go to 38. I think it'll take time, though. 37. Am I going too fast? Did I need to show you that longer? Want to try 37. Okay, let me get started. I'm going to set it up. So it doesn't say anything here about using the normal distribution, but oh, at the top it does, sorry. It says mean is 65, the same information from on top. X is normal with a mean of 67.5 and a standard deviation of 12.5. And then I'm going to take the screen. And then the top 8% of grades are an A+. So that means 0.0800 are A+. And the next 12%, so that will put you here at 20.2000 are A's. What is the minimum percentage a student needs to earn a grade of A? So we're going to use the Z for this and then go back. So in other words, we're going to do the 2 steps. So we need to use Z first because we know the values on the Z much easier. So there's a 0 there, and we have the table, we have Excel, we have all these sources to finding what the probabilities associated with being so far from the mean are. So at 20% over here, what is the Z-score?
It will be 0.84.
Okay, I'm just going to confirm. Let's go back and look for, we're going to go to the Z table, the -1, and look at 80.8000, right? No, sorry, the positive, because 0.8000 is not on the -1, sorry. We're on the positive table on the right side of the table or above 0. So 0.800 is over here. This is the closest, right? So 84, yeah, 0.84. Correct. It's the best we can do. So remark Z is equal to positive 0.84. And then for step 2, we find the score. We go from the Z score to the actual variable, the value of the variable, the score for X. X equal Z standard deviations from the mean. And I put in the numbers. So C is 0.84, sigma is 12.5, and the mean is 67.5. And whatever that gives you. $78. Any questions about that? I see different answers. I see mostly B's though. Good. So you might have gone wrong by using 12 instead of 20. You might have gone wrong there. Any questions about this?
Can I see the question again?
Yeah.
Professor, the 0.84 corresponds to the 0.08.
¿Otra vez?
What is? Okay.
Say it again, Orlando.
So the 0.44, the 0.84, the C value of or standard deviation of 0.84 corresponds to the 0.08. I got lost there because I
No,
had
it corresponds to 0.2.
0.2 to
Because
0.2. Okay, so
yeah, because it was 0.08 plus 12% put us at 0.2.
okay, thank you.
I'll put it here. Does anyone want to do 38 or should we stop? We can stop. Just going to show you on the problem. I just, if you're wondering where the 20 came from, I put it here. It's the 8% plus the 12% make 20. Because they said the next 12. That's going to get you here. And then I looked up 80% because the tables only give me the left side. So I had to look up 80 when I went to find this value. It's 20 on that side, it's 80 on the other side. It's 20 on the right side, it's 80 on the left side. Are we doing 38? Are we going to try it or we're going to say good afternoon? I leave it up to you.
Let's do it.
Let's do it. Let's do it.
Mari, let's do it. We're good. Good. All right. So try that and then we'll go. Okay, so this one's a little bit tricky, but once I teach you, you're going to be fine doing this. So the interpretation is this different than we've done before, but you have all the tools to do this. And the issue is, what does within 1 milliliter of the mean refer to? So let me show you. This is what I'm talking about. Okay, so within, I don't know the mean, but within is plus or minus, and I always use the arrows small and big, because I mean, you know, it goes that way, that means between. So that's my translation for between. So it has to go from small numbers to big, small to big. All right, so this is in between or within 1 milliliter. So you can standardize this, see what happens. When you standardize, you subtract each of them by mu. So you have, and then divide by 4. And this turns to C. And then you subtract this one by mu and divide by 4. So you're not hopeless. You have everything you need because this is going to cancel, and it doesn't even matter if you know what the mean is. So essentially you're looking because the standard deviation is 4 and you're looking within 1 of the mean, you're really looking between 0.25 negative and 0.25 positive. And that will give you the answer. Okay, and the option E that says it's impossible to calculate is to catch those people who didn't know this, didn't realize that they had everything they needed. So you don't need the mean to solve this, which is very interesting actually. But it's weird that you'd have a standard deviation and not the mean. Anyway, it's unusual. But without knowing the mean, you can solve problems around the mean. And so then you look up 0.25 negative, because that's the one, the left side is easier to get. 0.25, you look, wait a second. Yeah, we're just going to look, this is going to be the z-score, negative 0.25. So that's this one down here.
$40.52. Oh, no, 40.13.
Oh, I have this one. So it's 0, 1, 2, 3, 4, 5.
Oh, okay.
40.13?
Yeah. 40.13. 4, 5. Okay.
So it's going to be, okay, so if I draw it, it's very tight, 0.25. And so this is 40.13. And what about the other value? 0.25. 0.25 is up here.
7?
Yeah, 5987 right here. $5,987. And you take the larger one minus the smaller one. So is that one of the options? It's A. Let's see who got A. A. Very good. Very good. Okay, so that's good news. So sigue with your exercises. You still have things to practice, right? Oh, I can put there's midterms there. There are midterms you can practice too. If you're ahead, or you want to get ahead. Let's see. On the platform, there are midterms in the regression section, I think. Okay, so not here. So you're craving more problems. The midterm, oh, here they are. So down here under regression, review 1 and review 2. So what you could do is you can just try review 1 and review 2 and skip the regression problems for now until you review regression. And then once you get through regression, you can do them. That would be my recommendation. So you'll see they're just also multiple choice. That way you can ask me on Saturday or before. Has anybody started these?
No.
Did you see these? Okay, so there's
No.
about 30, I think there's 30 problems. Oh, look, there's more. And again, they just have the multiple choice answers. So you have enough problems to work with. That's why I don't want you to spend time on the book. You have a lot of stuff here before the book. Anyway, preguntas, dudas.
But, well, I'm hoping through it.
And the test is in English or Spanish?
I actually have it in both. I have it in Spanish and English. You have to let me know if you have questions about it because I just use Google to translate. So I did my best. Yeah. How is it going? If you're having trouble with the English, please let me know in advance. Yeah, so the review exercises are not in Spanish. The reviews are in English. I haven't translated those, but the exam will be in both languages.
Okay.
Okay, estamos? We're good.
Yep.
You're going to have a good weekend. You're going to do the reviews, and next week we're going to talk about regression. Do some, review regression before the test, before we meet next week. But it's a short chapter. It's a short module. The advice. Oh, let me tell you before you don't know this. Let me tell you that for regression, you do not have to look at all the pages for the notes. I say at the beginning. Do I say it here? See. Pages 13 to 18 are included for completeness. However, material covered in these pages goes beyond the scope that's required. So that's extra. I just put it there because some people have more knowledge and they want to tie it back into what we reviewed here. But it's only till page like 11 or 12 that's going to count. It's not a thick module. Okay. And you pick up, the discussion picks up from Unit 2, where I talked about scatter plots. So if you need to, go back and watch the scatter plot video, and you should watch the scatter plot video. Make sure we can see the same thing. And the scatter plot video is in module 3. If you didn't see it, watch it. You need that. That's on video 17 and 18. Video 17 and 18. And then these are some problems. So it's like 20 minutes of your time. Okay, so if you didn't see those, watch those. 17, 18, 19. 19 is I'm solving problems. Okay. Okay, so we're good. So have a good weekend. Have a good week. And keep in touch, all right?
Have a good
Okay,
weekend.
thank you.
Thank you.
Bye.
Thank you for everything. Bye bye.
Thank you. Bye.
Bye.
Bye.